Hello, so here's part 2 for Kirchoffs Law. As I'm going to do, I'm going to do part C, which now you have the internal resistance, and then part D that goes along with the internal resistance problem. So now your battery has internal resistance, so do it again. Okay, so we will. It's actually, although some of this changes, not by much though, I'll show you though. So let's go ahead and let's get a new page so we have a nice fresh start. Get my things ready to go. Let's do this one. Let's do it in this color. Okay. Let's get rid of this. I don't want this. Alright, so if we look at this, it's going to be roughly the same thing, except what I'm going to do now is basically just add the resistor here. Because that's the internal resistance of the battery, and same thing here. So essentially, by having the internal resistance, I'm just adding a resistor. And we know the value of that resistor, it's 1. It's for both. So what we get then is a new problem with an extra resistor. So I am going to do it again, even though you can absolutely take a shortcut. You just add it in here. That's the easiest way to do it. But I think I will just do it again anyway because it's just a good thing to see again when you're learning this. So I'm going to redraw that circuit with that resistor there. So resistor, battery, resistor. I think I can remember this. I'm gonna make sure I draw it the right way though. Pretty sure it was like this. Let's see how well my memory serves me. I think there is one other resistor. May not be there, but I think it's okay. Nope, that's definitely wrong. Let's do... Okay, we can actually look back. The resistor's there, and that's okay. So your battery's this way. Although the resistor really should go with the negative end. Let me draw that correctly. Negative end, positive end. And then the third resistor. So this one we said was 1, so that's 24. I think it's up here, but that's okay. It actually doesn't matter as long as it's on the same wire, which it is. This one was the 61 one. This is the 31. Now this was 12. This was 9. And this is 1 and 1. So I'm gonna go quick just so you can kind of see what I'm gonna do. Okay. So let's go ahead. Here's the current, I1. I'm going to let I2 go this way, and I3 do this way. I like to be consistent. I know this is the wrong direction, but I like to be consistent. So that gives me this equation for I1. Sum of the currents in have to equal out. And then we'll go ahead and just rewrite this in the format just because I just want to make this one quick. We'll just get this going. Alright, so that's the first part. I'm going to do the first loop right now, which is this one. Oh, I selected this one. There we go. Maybe. Okay. So when I go through this loop, yeah, this one. There we go. So that's my loop. So my loop goes around, and I go with I1, so it's minus I1, 24. I go with I2, minus I2, 61. I'm going, my current here, I1, is actually up over here if you continue this. So let me just show you, because technically I1 is all of this. So I'm actually going with the current with the loop, so that's a negative. So that becomes negative I1, and then times 1. You can just leave it there, but I'm showing you that I am considering it. And then we go up, so that's 9 volts right there equals 0. And then if I rewrite it in the form, notice I have this extra I1, so that combines with this one. So what I'll get is minus 25, so I have I1s combined. And then I get minus 61 I2 plus 0 equals negative 9. And then that's it. So here's my loop down here. So I'm with the current there, so I get minus I3 31. I go and lose energy through that battery. Oops. Yep. And then over here, I'm going with the current because remember I3 keeps going. All of this up like that. So that goes through. So in other words, we get I3, and it's negative times 1. And then I go against I2 because my loop is this way, but I2 is, my loop's to the right, this is to the left, positive 61. I2. And then, like I said, I'm going to rewrite this in our form, so let me do that. So I3, so notice that this one will combine with that one. So I don't have an I1 plus 61 I2 minus 32 I3 equals 12. Now, the 12 is positive because I moved it over, and this is 32 because it comes from the negative 31 plus negative 1. That makes negative 32. So, that's what changes, which means my matrix looks different, but not by much. So, remember I1, I2, I3, my first matrix is 1, negative 1, negative 1. This one changes to negative 25, but the rest of them stay. 61, 0. This is 0, 61, and this one changes. So 2 factors changed when we did this. And in fact, our matrix is matrix A. Our matrix B is actually the same. It's 0, negative 9, and 12. So what you could do is, very nicely just change those numbers. And when you solve this, you get 0.025, 0.137, and then 0. This is negative 1, 1. I think it's negative. Let me just double check my calculator. Yep, it's negative. 1, 3. And that's I1, I2, I3. And the directions are pretty much the same because the I1 is to the right. Oops. This is to the left, and this is up. So that kind of refers back to there. So I did go through this kind of fast, and I just wanted to make one more point since I have a little time left too, is why am I doing this? So what an internal resistance is imagine you have a battery, okay? Here's my battery. And the battery is going to have some voltage, so I'll draw the battery symbol right there. But what happens is inside that battery, there's what is called the internal resistance. That occurs from when you put current through the battery. You have basically turbulence from your chemical reactions that slows the chemical makeup of this. I don't know much about it, but I know that it slows down, and that's why we call it internal resistance. So when it asks for the internal resistance in a circuit, what's common to do is, if this is your battery right here in a circuit, what people normally do if there's an internal resistance that needs to be considered is they put the battery there and they put a little resistor next to it. And usually this dotted line right here is the battery with the internal resistance. So that's why I was able to just add the extra resistor in there. because we pretend more or less that we have an internal resistance. Let me just, right here. This is the battery, this whole thing right here. Like that. Okay, I hope you found this helpful. I'm going to take a quick pause to see if I can actually pull up a calculator so you can see what I'm doing. Okay, so I managed to find some online thing to help show you the matrix part. So I'm at this website. I just Googled matrix calculator online. So that's what I did. And well, it's not going to seem like you waited, but while I was doing this, I plugged in our numbers of this is the first problem. So here's all the matrix numbers, matrix A, and then matrix B. And what I did here is do the calculation. So A to the power -1 times B, and if I press enter, here we go. I don't know why there are two. There we go, right here, perfect. And there you have it. Here are the values of your calculation when you do it out. So this is from the previous problem, and then the other problem we just did now is this becomes -25. This becomes -32. And then I'm going to go ahead and do it out. And you can see the slight difference. It's slight, but yeah, so you can see the values right here. So here's how you can use this online matrixcalc.org. This can help you with your Kirchoffs Law problems if you don't have a graphing calculator or don't understand how to use your graphing calculator. This will hopefully clear up some things. Definitely give it a shot, as I think your numbers might be different. All right, I hope these videos help, and best of luck.